Now let's jump in the second part of the demonstration. In this part, we will be the governor interacting with the deploy smart contract flow, the send transaction flow, and the call method flow. Okay, I'm connected to the instance as the governor now, and let's have a look to the Ethereum application. So in the Ethereum application, I have the object of the data model that we have described so far. I have networks and three main networks defined. Kovan and Ropsten are public testnet, while MyQuorum is a private network that I'm running. Each network have one or more endpoints that are actually the URI of the nodes where the connector connects. In this case, I'm using nodes from the Infura infrastructure service that allow access to the Ethereum blockchain. Then I have the smart contracts, and I have two smart contracts loaded in the local library. At the moment, we will use both of them. The first one is called storage, and it's just a contract that defines a single storage slot that we can deploy on the blockchain, and we will see how that works in a moment. The second one is the ERC20 token that we will use for the creation of the now token application. Each contract contains the bytecode, that is the executable of the program that we deploy on the blockchain, and we can compile that offline. And the ABI, that is the programmatic interface to the smart contract with method and events. Then we have the smart contract instance that we will deploy in a moment, and it's also important to see the balances. So every user on an Ethereum blockchain has a balance of Ether. For public network, this is important because the user who send transactions to the blockchain need to have more than 0 Ether in order to pay for the transaction fees. On the other side, on the private network, this is not required as the cost of transaction is 0 on this kind of network. So if I filter by the Kovan blockchain, for example, I see that my user Alice, the governor, and the token administrator actually have non-zero Ether balance on the blockchain. Good, so as a governor, I'm able to deploy a smart contract on the blockchain, so let's do that through the catalog item. So I want to deploy my smart contract on the Kovan public network. This must be the storage contract, and the storage contract is very simple, doesn't require any constructor parameter to be deployed. The account is going to be one of the account available to the governor, and there is just one, so I will pick up this one and request. So this is the requested item. Let's open it, and let's have a look to the flow. So this is the flow that just deployed the smart contract instance. All the activity is done in a subflow where I can find a series of actions that actually do all the heavy lifting of deploying the smart contract. I will not go through the detail of each one, but I will point out to the creation of the payload as we just saw. This is the payload that is determined by the flow. Then I will point to the sign transaction, sign payload, and submit raw transaction. And here again, I have the raw transaction that is sent to the Infura node. And then I want to show the action that create the smart contract instance within ServiceNow. That is a record that I can open in the table. The smart contract instance gets a name assigned automatically. It's deployed to a specific Kovan blockchain address. This is the contract that I have deployed. I have again the ABI, and I can open in the Blockchain Explorer the smart contract instance and see all the details about that. For the moment, I have just the transaction that has created this smart contract. In the same way, I can go back to the smart contract instance and I can see the transaction that has deployed this smart contract instance. And I can open this object in ServiceNow that is kept for auditing purpose. And again, from here, I have the possibility to go to the Blockchain Explorer and see the details of this transaction in the Blockchain Explorer, where I have additional information like the block number and like the timestamp, for example, that are actually the same information that I have within the receipt, that is the return from the blockchain regarding the execution. Okay, let's close the transaction. Now what I want to do, I want to send a value to this memory slot of the blockchain and have that stored permanently on the blockchain. To do that, at the spoke level, I need to send a transaction to the smart contract that I just deployed and specify which number in the parameters of this method. So what I want to do is select the method. So this is going to be the method to store a value at the storage smart contract. The parameter that I need to pass is made by just one value, so I can say 42, and the account must be one of the account assigned to the current user, in this case the governor, and I'm going to pick up the only one that exists and request. So this is the request item. Let's open it and let's have a look to the flow. This is the flow that just submitted the transaction. Again, all the activity is done in a subflow that do all the heavy lifting. Again, here I have activities like create payload, that is the payload of the transaction, and sign and submit the raw transaction to the blockchain, and this is the raw transaction that has just been submitted. And then I'm getting the transaction receipt within the flow, and this is the receipt associated with the transaction that I just sent. So let's close the flow designer and just have a look to the smart contract instance from the Remix interface. So let's do one thing. Let's take the address of the smart contract once again, and let's go to Remix. So Remix is a development interface for smart contracts and deployment on the blockchain. This is the storage smart contract that we just deployed that has two methods, store and retrieve. And let's have a look to the smart contract deployed on the network. So I'm connected through MetaMask here to my Kovan network, and I'm going to take the instance of the smart contract storage at the address that we just deployed. So this is the smart contract instance. So as you can see, you have two methods, store and retrieve, and we can ask retrieve, and we just get the 42 number that we just sent. The same kind of operation we can do through this to the spoke or the API within ServiceNow. So let's open once more the Flow Designer. And let's call the method that we just called from the Remix interface that allows to retrieve the current value. So let's select retrieve this way. I don't have any parameter. I want to select the account. In this case, I will take governor. The other one will be stopped by the flow. And let's run. This is the flow that has just been executed. In this case, no transaction is involved. we just send a request to the node, the Infura node to which we are connected, in order to have the results from the call invocation, and the result comes to the decode action, and you can see here that we have a 2A blockchain likes Xcode, and this is just the X for 42. Okay, let's do one last thing here that helps me um, introduce the next step of the demonstration, and let's deploy the token smart contract now. But this time I want to deploy not just on the public network, but I want to deploy on my private network. My Quorum network, by the way, runs on a cloud system on DigitalOcean, and I can see here the process GIS that compose my private blockchain that is made by 3 nodes. So in this case, I want to deploy my token 20 contract, that is an ERC20 based contract. In this case, the parameter that I need to pass is the supply, the total supply of the token that I'm going to create. What is important to emphasize is that supplies are defined in integer number, and there is a parameter of the token that is the granularity, that is the number of zero that are taken after the comma. So because this must be an integer number, it's going to be a huge number. So by default, the token takes 18 zero after the comma, so that means that um, that one token will be equal to 10 to the 18th um, of the supply. So I'm going to have, in case I want to create a token that has 1 million total supply of now token, I will need to type 1 million, and then I will need to put extra 18 zero in order to be able to define this supply. And because this is a very big number, I need to put it as a string. Okay, so these are the complexity in dealing with constructor parameters because they work at a very low level in the blockchain. So to make it that work, I still need to specify my account, and in this case I will publish my smart contract again, not on the Kovan network, but on the private Quorum network with my governor account. Remember, account addresses are equal across all the all the different networks, so they are valid across all the different networks. So let's request this deployment. This is the deployment of the smart contract. And again, let's have a look to the flow. Again, all the activity were executed correctly. And here I have the smart contract instance, and I can open the smart contract instance in the table. This is the address of the smart contract instance. As you can see, there are a lot more methods now in my instance. Let's have a look to this object in Remix. So here I am in Remix. In order to see the contract, I need to switch to the Quorum network, and the token 20 contract is the one that is just selected, that has a very short code because I'm basically using a token standard as a foundation for this program. If I want to see the contract on the blockchain, I can copy paste the address and get the token. As you can see, there are a lot of methods here. Um, The blue one are the read, the gold are the write method, and I have the total supply method that tell me how many token supply I have for this object. And as you can see, I get my 1 million with 18 zero in addition. Okay, this ends the second part of the demonstration.